Hello, we're going to continue with chapter 3. We are dealing with finding the equations of a line. Okay, so let's look and see what I have. All right, so with chapter 3, we have already gone over plotting points, graphing a linear equation, looking at the different types of equations, looking at the slope of these lines, whether it's a positive slope, negative slope, zero slope, or undefined slope. Okay, and so we've also gone over how to find the slope. So at this point, we're going to find the equation of a line. How do we find the equation of a line? Now, we're dealing with three forms. We have the slope y-intercept form, which is in the y equals mx plus b, where m is your slope and b is your y-intercept. And so if you are finding the equation of a line, we need to know what the slope is and what the y-intercept is, okay, in order to use this one, okay? The next form is the point slope form. Point slope form is y minus y sub 1 equals m times x minus x1, where x1, y1 is a point on the line, okay? So you can pick any point on the line. As long as you have a point and a slope, you can use the point slope form. And now note that the point slope form can be converted to the slope y-intercept form, okay? We can manipulate this equation to fit this form, okay? Now the last one is the standard form, okay? Normally, if you found the slope y-intercept form or if you found the point slope form, both of these equations can be converted to the standard form, okay? The only thing is, you notice that x and y are on the same side, okay? And note that a, b, and c should be integers, okay, when you write it in the standard form. All right, and so we've gone over, if we have it in standard form, we can find the slope by using the form negative a over b. Okay, so that's another way of finding the slope. So what we're going to do is look at some of the problems that is in my math lab. Okay, so you go there. All right, so in my math lab, you should have already enrolled in the section for the class, the 1 o'clock class. And so here, the first assignment is open. Homework set 1 is on chapter 3 as well as chapter 9. Okay, so there are a few concepts for chapter 9 that we will cover in this first homework set. So we've gone over some of them, okay, but let's look at, there were some that we skipped over because it dealt with the equation of a line. All right, so let me see which ones they were. Okay, so this is one. Let me make sure 17 is not 1. Okay, so let's start with number 18. Okay, so this is an example very similar to yours. All right, it says for us to write an equation from the line shown on the right. So we look at this line. Now, with my eyes, I can barely see the points on the line, so we can use the magnifying glass, okay? All right, so what I'm going to do is to put this on my sketchboard. All right, so I'm going to do a screenshot. Okay, so now I can write on it. And so if we have to write the equation, okay, if we look at this, what do we notice? Okay, they give us clues. And so this point right here, what are the coordinates of this point here? Okay, so it's on the y-axis. Okay, if it's on the y-axis, it is a y-intercept. All right, so that's the y-intercept, okay, at 7. So that means that we have a b equals 7 because that's the y-intercept. Now, so if we need to put this in the form, because they want the form in the y equals mx plus b form, okay? This is the form they want. So we know we have b. We have b, can we find m? Well, we're given 2 points and we're given a graph. So we can actually use the rise over run, okay? So we can use rise over run, okay? All right, so I gave you 4 ways of finding the slope, and this is one of the ways that you gave me, the rise over run, so we can just count. So let's suppose I'm starting with this point, okay? Then I go over to the right, which is a positive movement. Then I have to go down, which is a negative movement. Okay, so already we already know from the definition of slope that this is a negative slope. Okay, we already know the slope is going to be negative. So let's count. We went over 1. Okay, and then we went down 1, 2, 3, 4. Let's see, 1, 2, 3, 4. So we went down 4. So that's negative 4, right? So the rise, which was actually a fall for us, is negative 4, and the run was a positive 1. So we have the slope is negative 4 over 1, which just simplifies to negative 4. Okay, since we're writing the equation. So we have b and we have m. So therefore, the equation is y is equal to negative 4x plus 7. Okay, this is your equation of your line. Okay, now notice when you're writing the equation, the x and the y in the final equation is not replaced because they're arbitrary. They can be a number of values. Okay, and so this is the equation that represents this line right here. Okay, so it's almost like a business equation. Okay, so basically this is the equation you use to represent to get the points on this line. That means if you plug in a value for x and input it, the output will be the y, which will still be on this line. Okay, so that's how we do this one. And if you go back in and if we put in, so see, they already have y equals, so you don't want to put y equals in there. Okay, so we did negative 4x plus 7, I think. Let's put it in and see. I can't remember. Very good. So we got that one right. All right, so that's finding the equation where you were given the slope and the y-intercept. Now here, they didn't give us a graph, but they told us to write an equation of the line with the following slope and y-intercept. They were giving us a y-intercept, but they write this as a point. So let me use my board. Okay, let me sketch this. All right, so they're giving us the slope, which is 7, and they give us a y-intercept, which is 0, negative 6. Remember how we said to find the y-intercept? Yn, that means that x is out. X is always 0, okay, when you find the y-intercept. So we are given m, which is 7, and we're also given a y-intercept, which represents b, which is negative 6. So we're given everything we need, right? So the equation of this line, now notice that they didn't put y equals, so we have to write the whole thing. So y, and they want us to write it in slope-intercept form. So y equals 7x minus 6. This would be your equation of your line in slope-intercept form. Okay, it's actually slope y-intercept form. Okay, is that hard? Okay, very good. All right, so that's 19. Okay, now this one here is slightly different. It says graph the equation by, okay, we've already did that one. That's not the equation. Okay, we did that one. Okay, graph the equation. So we'll deal with, let's see anymore. That's graphing, graph. Okay, here we go. Again, we're writing an equation of a line through the point, this point, and having a slope 6 over 7. And it says write the answer in slope-intercept form. All right, so let me put that on the board. And let's see, how do we tackle that? All right, so we're given the point and we're given a slope, okay? But they want us to put it in the form, the y equals mx plus b form. Now, there are different ways you can go about doing this, okay? You can either use the point slope form since they give you a point in the slope, and then you would have to convert that to this form right here, okay, which is not bad. Or you can just use the slope y-intercept form, replace the y, the m, and the x, and solve for b to get b. All right, so let's look at it. Let's look at it this way first. Okay, so if we know we need to put it in this form, we're given the slope, but we're not given b, but we are given a point. So we can replace the x and the y and the m and solve for b. So the y, remember that the ordered pair is x first then y. So that says that 7 is equal to 6 over 7 times -6, and then plus b. Now this goes back to being able to solve a linear equation dealing with fractions. Now remember that, let me see if I can use a different color. No. All right, so if we put this over 1. All right, so we have 7 is equal to, when you multiply the top. So that's -36, and multiply the bottom numbers. That's over 7 plus b. Now, how do you solve for b? Okay, so to solve for b, well, you can deal with the fraction, or you can get rid of your fraction by multiplying everybody by 7. Okay, you can do that also. So the LCM is equal to 7. So we can multiply everybody by 7. Trying to find a different color. All right, so multiply by 7. So no different color. So multiply this by 7. Then I have -36 over 7 times 7, and then plus 7 times b. So you have to multiply everybody by 7. Okay. So now we have, and this is 7 over 1 since I'm dealing with a fraction. So this is 49 is equal to, now notice that these 7s cancel because they go in each other one time, so that just leaves me with -36, right? Plus 7b. Now we have no fraction. Fractions are gone. And so solve this as you did on your pretest. All right, so how do you solve for b? Okay, add 36. And so we have this cancels. My equal sign is down. On this side, I have 7b left. Okay, and then I have to add this one. So I get 85, right? So because 49 plus 36 gives me 85. Now, how do you deal with this, get b by itself? So you divide by 7. And of course, I still have, a fraction. 85 and 7 have nothing in common. And so b is just 85 over 7. So I know what m is. Slope is 6 over 7. And b is 85 over 7. Okay, so now are you able to write the equation in the slope y-intercept form? Okay, so yes. Okay, I have b. I'll write this on my paper so I can remember it. And I have the slope. All right, so let's go back. Oops, and put that in and see if we are correct. So I have y is equal to, and we have 6 over 7, and then that's times x. No, that's at the bottom. You see how that did that? So you want to click on the right arrow, okay? That's on your computer. You have a right arrow. So that takes it up. And then minus 85 over 7. Okay, and let's see if we are correct. Uh-oh, sorry, we did something wrong. What did I do? Okay, it shouldn't have been a minus, right? Let me look at my sketch. No. Did we get plus or minus? So let's change it. And if you do get it wrong, okay, it will allow you to correct it. All right, so let me see. Oops. My error. Okay, delete that and put a plus, and let's put a 7. I can't remember what I did. All right, so let's put a 7. I see, maybe it was plus that we had. So let's check that. Good. So I don't know how I put a minus on my paper, but it's plus. We did the work on the paper, so that's what it is. So if you do get it wrong, it will give you another opportunity to correct it. All right. So that was finding. Now I wanted to do it the other way also. So let's see. All right. So I wanted to do it. Let's sketch it again. Let me put it on my sketchboard. Now, some of you probably wanted, if you wanted to use the y minus y1 is equal to m times x minus x1, you can start off with the point slope form, okay? The point slope. You can start off with the point slope form, okay? But look, this is what you have. So we have a point, which is negative 6, 7. That would represent the x1 and y1. So we have y minus 7 is equal to the slope, which is 6 over 7, times x minus a negative 6, okay? So minus a negative 6 becomes what? Plus 6. Very good, okay? So now this is what you're looking at. Now you would need to put it in the form of y equals mx plus b. So that means that I have to solve the equation for y. So how do you do that? Okay, well, over here, we would have to apply your distributive property. So we have y minus 7, and I'm distributing a fraction. So 6 over 7 times x is 6 over 7x. And then I have plus 6 over 7 times 6. All right, so that's 6 over 1. So how do you deal with this? All right, so we have y minus 7 is equal to 6 over 7x. And then you multiply the top, you get 36. Bottom, you get 7. And so now, how do I get rid of this minus 7? And I have to add 7 to both sides. I'm still dealing with a fraction here. I'm dealing with a fraction. What I could have done before doing that, since I had at this point right here, I could have multiplied everybody by 7. That would have eliminated the fraction. Or if you want to just deal with the 7 over 1, you can do it that way. So how do you want to deal with this? Seems like you want to, okay, we can, at this point, okay, so since we have fractions, the LCM is 7. Multiply everybody. So I have 1, 2, 3, 4. You have to multiply all 4 terms by 7. Okay, won't work any other way. So I have 7 times y, which is 7y, minus 7 times 7 is equal to 7 over 1 times 6 over 7x, plus 36 over 7 times 7. That's 7 over 1, okay, since I'm dealing with fractions. So now once you multiply this through, your fractions should be gone. So I have 7y minus 49. That 7's cancel, so that gives you a 6x. And then these cancel, so that gives you plus 36, correct? All right, so now what? No more fractions. I still need to put it in this form. Solve for y. So now add 49. All right, so let me move. I'm gonna move it over here. All right, so we add 49, we get 7y is equal to 6x, okay, plus 85. Now what? Divide everybody by 7. And so therefore y is equal to 6 over 7x plus 85 over 7. See, we still get the same answer, okay? So either way, if you start off by just using the slope-intercept form, you can do it that way, okay? Whichever form you feel comfortable with. But if you start off with the point-slope form, you have to convert that to the slope-intercept form, okay? All right, so hopefully you got that. All right, so remember, when you're multiplying by a fraction, put the whole number or the integer over 1, okay, so you can know who you're multiplying by. All right, good. So that, let's see, 25, we did that. All right, so that pretty much takes care of finding the equation of a line. Now, there are a few more things that I wanted to just bring to your attention. All right, so if we look at this, let me give you New. Okay, all right, so dealing with parallel and perpendicular lines. Perpendicular. In terms of slope, okay? All right, so note that, all right, so note the following, okay? Parallel lines have the same slope, okay? Because they go in the same direction, okay? They go in the same direction. So this is just an example. So therefore, so if the slope of line 1 is equal to 3/4, okay, and line 1 is parallel to line 2, okay, so then the slope of line 2 would be equal to what? What would be the slope of line 2? So we've already established that the parallel lines have the same slope, okay, so therefore, good, so it would be 3/4 would be the same. Very good. Okay, now let's note that perpendicular lines, okay, have negative, oops, let me put, hold on. Have negative reciprocal slopes. Negative reciprocal slopes, okay? And so perpendicular lines, they form right angles, okay? So this is just an example. So that means that if slope of line 1, let's say is negative 3/4, then the slope of line 2 is equal to what? Okay, so we said that perpendicular lines have negative reciprocal slopes. And so when I say negative reciprocals, that means they have the opposite sign, and reciprocal means you flip it, okay? So the opposite of negative is positive, and then you flip the 3/4, so that'd be a positive 4/3, okay? So you want to keep that in mind when you're dealing with any application problems in reference to parallel lines and perpendicular lines, okay? All right, so I hope this has been helpful. You should be able to complete the homework. If you have questions, please let me know.